Picture this, a boundless stretch of open sea, two large ships collide. And this is not at all uncommon, but how is this even possible? Well, well, in most cases it's a human error, but what is interesting is that many times when the crew realizes that they are going to collide with another ship, it's already too late to react and to do anything about it. This is because of the ship's inertia in the water, resulting in its inability to change direction on time. The same characteristic can apply to organizations. We could call this characteristic agile, business agility, or adaptiveness. But companies do not collide with each other. Rather, adaptiveness or business agility helps them to navigate and stay relevant around the competition on the market. We could call this business resilience. What would be the North Star of agility for your organization? Would be the possibility for the organization to work on whatever is important, whenever, and no extra costs. So as a CEO, you should focus on improving the clarity or on where to go, on increasing the speed of the turning the ship, and on reducing the cost of doing the turns. So what does this mean? Agile is dead. Why organization let go currently Scrum Masters? Is it because our community failed? Well, I would say it's most because how organization introduce change. So some organization introduce change because of their strategy, something Alexi and Roland talk with the STAR model, as you remember. Some organization introduce change because something urgent happened, like COVID, for example. But some organization just do some stuff because everyone else are doing this. So right now, every organization are letting go the Scrum Master and Agile coaches because everyone else they're doing this. So where do the leaders and the C-level currently seek answers on where and how design the organization? They go back to people that solve their problems, other problems, the software developers. What is the problem with software developers is that they don't design experiments and they don't use system thinking to introduce change. Why is that? Because they are not used to. A typical developer writes some code, press F9, the code compiles, the test runs, and he already or she know if he did proper reasoning or not. So how do developers actually make decision? They use common sense. The problem with common sense is that it's actually not very common. So let's use this causal loop diagram of shifting the burden model to explain this. So the leaders in our organization don't bring us the problems to solve. They're bringing us the symptoms of the problems. And we can solve the symptoms of address the symptoms of the problems in two ways. One, by planning fundamental solution. The problem with fundamental solution is when you apply it, you need to wait to the symptoms to disappear. Or second, you can apply the symptomic solution, but it actually doesn't solve the problem and introduce side effects. So for example, I smoke cigarettes and I have a cough. So I could apply the fundamental solution, which is just quit smoking, or I could just take pills for coughing, but after a while, I have the side effects from the pills, and additionally, the friends that would notice that I'm sick because of smoking don't notice. So, hello, my name is Błażej Drobniuch. Tomek already introduced me. So today topic will be about the topics that are right now appealing to software developers who are making the organization design decisions. Topics like Conway's law and the inverse Conway's maneuver, like cognitive load and team cognitive load, like code ownership and team ownership, and last but not least, having to fix someone else's shitty code at 2 a.m. This will be an interactive presentation, really intense, so prepare after lunch to be engaged. This is the only time I will show this QR code, so please don't close your browser. And in a moment, I will engage you in some questions. But before asking the first question, I would like to introduce you the first topic. Thank you for the emojis, already 45. Everyone scanned. I would like to introduce the first topic, which is Conway's law. Who of you is familiar with Conway's law? Oh, many of you. Great, great. So, Conway's law. Organizations with design system are constrained to produce designs which are copies of the communication structure of this organization. What does it mean in layman terms? Well, complex products end up shaped up, look like the organizational structure they are designed in. So, because it's hard to see software, so let's use a metaphor. Let's imagine we design an organization that wants to draw a paint a painting. And we structure the organization where each group of people owns the part of the painting. Can you imagine how the painting would end look like? If you can't imagine, let's ask for help. Let's generate a painting of the same landscape painted by 6 artists from different eras, which artists paint only their design part of the painting. So we see one landscape, but we clearly see the Conway's law in action. So Conway's laws are a real thing, and we need to take it into consideration when we design our organization. So the first question to you is, should the organization map its structure to the desired architecture of the product if Conway's law are really in action? So to rephrase this, this is, by the way, the inverse Conway maneuver. So we actually design the teams into the desired architecture of the product. So I get answers. Let's practice answer quick. Before I comment this, I have a second question to you. What is the probability that the architecture of the product will change over time? Not surprising, yeah? Okay, so we think it's a smart idea to structure your teams into the desired architecture, but we know that it will change? So, who of you actually read the Conway's paper from 1976? Okay, yeah, so this is the problem in trending trends. No one reads the original paper. So at its very ends, we read from Conway's. Because the design which occurs first is almost never the best possible, the prevailing system concept may need to change. Therefore, flexibility of organization is important to effective design. So back then, even Conway didn't recommend component teams. He recommended to design flexible organization, and he introduced that ways must be found to reward design managers for keeping their organization lean and flexible. Okay, so how to address Conway's law? Well, let's ask another question. Now the same artists paint a landscape where everyone can contribute freely with no distinct sections. What do we see? No Conway. So you have Conway's law because people don't share ownership. If people share ownership, there is no Conway law. This is how you avoid Conway's law, not by designing your organization into the desired architecture, by shared co-ownership. Let's jump to another trending topic, the cognitive load. Who of you already heard in IT the term cognitive load? Yeah. So let's first read the definition. Cognitive load, the total amount of mental effort being used in the working memory. So it's only about our current mental memory while we're working. It has nothing to do with learning. We don't have a learning limit. We only have a forgetting limit. After a while, we forget knowledge. That's why it's important to refresh it. But cognitive load has nothing to do with the stress of the teams. But unfortunately, right now in IT, cognitive load term is used not to actually show what is in psychology, but to just reflect team stress. So for the sake of being nice to developers, they introduced the concept. Yeah, it's challenging. So they introduced the concept of team cognitive load and cognitive load. So team cognitive load isn't even a psychological term, but it's used in IT. So let's use the proper term, which is not cognitive load but team stress, and go back to our shifting the burden causal loop diagram. So we have team stress, and we can apply fundamental solution, which is spend some time on helping each other and learning, but this requires time to reduce team stress. Or we can introduce symptomic solution, which is to introduce component teams. So component team is a team that owns part of the product and only that teams owns it. So it could be architecture component or a couple of microservices. What is the problem with that? If we introduce this, Conway's law are in progress. So if we introduce component teams, then we introduce more time spent on primary specialization, which of course reduces team stress, but introduce the side effect of skill gap to developers to develop top features in our company. Okay, why is that? So we have 3 beliefs that we need to challenge. First belief is you can't require from a developer to work on the whole product code base. Second belief is multifunctional people do not exist. And third belief is that it is most efficient when everyone are busy with their work. So you've probably came across these beliefs. Let's challenge it with common sense. First question. This is the hardest question today, so read it carefully. What is the percentage of features in the product backlog of your big product where the team, in order to deliver that features, needs to know and understand 100% line of codes, 100% architecture, and 100% technology of the product? How many features in your product backlog are there that require you to know and understand this? From my experience, there are 0% of features that require you to understand whole code, whole architecture, and whole technology. Why is that? The feature team that develops the feature only needs to understand and learn about that feature. So for example, that team first draw the left eye, so the next most valuable thing that can deliver is maybe the right eye or the eyebrow. The team doesn't need to know the whole product to do this. Another question, what is the percentage of features in the product backlog where the developer, in order to deliver them, needs to know and understand 100% front-end technologies, frameworks and tools, 100% backend technologies, framework and tools, and 100% UX, QA, and DevOps? Also 0, yes? It's not, there's no feature that requires 100%. There's no feature that even requires 80% or 60%. The bigger the product, the less percentage of the huge product code base you need to know. As I work as a software developer in Ericsson developing the base station for the mobile phones, there's no human in the world that could understand the whole technology stack used there. But we as a team didn't need to understand the whole architecture, whole code. We only needed to learn what is needed next to develop that feature. So we challenged the 2 beliefs that you can't require from a developer to work on the whole product code base. It's not true. You can, because the developer doesn't need to understand the whole product code base to work on the whole product code base. And second belief, multifunctional people don't exist. Here they exist. It's only about mindset that I'm open to learn another thing that I don't know. That the team from AI already mentioned on Alexei's and Roland's talk were a great example. That there weren't like I am front-end developer. No, I'm doing everything what's needed to make my product great. So let's maybe challenge this. Is it most efficient when everyone are busy with their work? So front-end developers with front-end, QA with QA, and component teams of API team should work on the API component. So what is the likelihood that a customer-centric feature will require work in exactly one component? Usually, customers don't care about how you structure your architecture. They care about end-to-end solutions. So the more components you have, the likelihood that one customer-centric feature is exactly for one component team is really small, yes? So if this is true, then what does a team do when blocked by another team do? Because yeah, if the customer end-to-end feature require me to work with multiple component teams, what does a component team do when it waits for work of other team? Complain, wait, learn new skills, try to survive, help, open next task. So start upfront work, ping other teams. Should I move it manually? Complain, wait, go to a call, lose time, create ticket for them. Yeah, so yeah, these are all valid options. So the work in progress goes up, and we also start work from that we shouldn't maybe not the most valuable right now. So while waiting on this task, we start working on another task. So the question to you now is, what do you think if we structure our organization into component teams that depend of each other? What is the percentage of time in the life of the feature with multiple component teams where no one actually works on that features? So there's a feature, component teams 1 start to work on it, then stops, then give it to component team 2. That component team was busy with another feature, so the feature waits. Maybe that component team 2 will start, then go back to component 1. Of course, there are some merging problems. So from my experience, the time that no one actually works on a feature is 80%. So we drastically increase our lead time. What is the percentage of team working on the most important business feature if each owns a component? So another question. We structure our organization into component teams. What do you think? How many teams? 10. We have 10 teams. How many work on actual top features? Do all of them work on the top features? We already stated that if they are blocked, they start working on something else. My experience is that around 36, so the same as the group experience here, percentage of component teams actually work on what is most important. So we also debunk this belief that it is more efficient when everyone is busy with their work, because it's not. Because what counts for us is the lead time. So let's expound this causal loop diagram. So we introduce more component teams. When we introduce more component teams, the number of dependencies between those teams go up. The work in progress goes up because the teams who are blocked start working on something else. So following little law, what happens? The lead times goes up because of this and this. Additionally, if we increase the number of teams, component teams, what we get, that percentage of teams that works on what is most important goes down. So imagine you are a CEO and your company is delivering a feature for 9 months and only 2 teams of your 13 teams who are working on what is most important. You get stressed. You get organization stress, and this follows up with team stress. What then does the CTO do? Either apply fundamental solution and go again creating more component teams, which is a reinforcing loop, as you can see, a vicious cycle. Okay, yeah, but those that can change everything owns nothing. Another belief. Let's challenge that. where do you get better code quality? What do you think? Where every part of the software is owned by exactly one team? So I'm a software development team, I'm a component team, I own this code, no one else can damage this code. Or where multiple teams share their code base. Yeah, I see we are at the LeSS conference, so I'm happy with your answers. But why? So, what is the probability that the component team will share with you that you deliver crappy code? Have you ever heard from a component team we deliver crappy code? Personally, I never heard from a component team that we deliver crappy code. I always heard, we are great, we deliver great component, it's so great, so great. So I'm surprised with those answers. Maybe the question wasn't so clear. But now, what is the probability that when another team takes a look at the team's code, they will report that it's crappy? Yes, of course, especially in Poland, because we like to complain about others. Okay, so how we can summarize this? You hear more complaints about the quality of the code when multiple teams share their code base, not because the code is worse, but because you finally received feedback about it. One more question, because as you know, software developers don't write all the code all the time. Software developers spend most of their times reading and understanding other code. So the top crucial thing is how to write easy to read code. Where we get more easy to read code? When the code is rarely read by others, or where the code is frequently read by many people? Cool, so we see if we have shared co-ownership, we got a lot of feedback. If we got a lot of feedback, we got a lot of learning and also code quality. How do developers learn? The same as musicians, the same as painters, the same as poets. They look at great work and copy it. So if you restrict the code base to individual teams, you actually reduce the possibility to the developers of your company to learn. So, what belief will help us to actually go to the fundamental solution, which is spend more time on learning and helping each other to learn? People may learn and acquire new skills over time. So, let's take a closer look on this. If we actually apply spending time on learning and helping and sharing knowledge, we actually improve our organization business agility or adaptiveness because we reduce lead time and most of our teams will work on what is most important. So as a CEO, we need to understand this. Changing direction of our organization is actually a learning cost. Shift becomes much cheaper if your organization is already learning. So, if you want your organization to be agile, don't do what the agile organization do. So it's not about practices. It's to do what they did to become agile. And they focused on becoming a learning organization. So, agility requires multifunctional learning. We need to understand this. And as leaders, when we understand this, we can actually set learning objective goals and create incentives and pressure from management to introduce extreme programming practices like pair programming, mob programming, living documentation, and many more. So don't reduce cognitive load and the learning by introducing component teams and reducing the ownership to team level. Reduce the cognitive load and introduce organization learning by applying this. So, one more thing to ask to you. What is the healthy time frame for a product's code base built by professionals to detect when something broke, someone broke it, and where is the issue. What do you think? Software developers, professional software developers? Okay, most of you answered that the healthy time frame for product code base to detect when someone broke it is less than a day. So let's go back to the last argument of the topics I wanted to share with you. Getting to woken up on 2 a.m. Because a service goes down. So the topics we covered are from this book, Team Topologies. Don't read this book because it's full of BS. If you don't want to be waken up at 2 a.m., you just silence your phone, and as a CTO, focus on what is really the fundamental solution, which is not who to blame because the code is broken at 2 a.m., but because actually the fundamental solution is to get a software engineering practice that can make us learn and not get and wake up at 2 a.m. So, Conway's law and the inverse Conway's law maneuver. Don't do the inverse Conway's law maneuver. Conway never recommended component teams. Cognitive load and team cognitive load. It's an excuse for team stress. Of course, there's a thing, it's a real thing, but don't address the team stress with reducing the code ownership and introducing component groups in your organization. Code ownership and team ownership. If you want learning, if you want code quality, you don't want to reduce code ownership, you want a shared code ownership. So remember, strategy of the commons, it's already debunked that we can address strategy of the commons. And having to fix someone else's shitty code at 2 a.m., don't read the Team Topologies book. Instead, read those 4 books and more. And feel free to scan this QR code and follow me on LinkedIn. Yeah, vielen Dank.
Thanks.